Assalamu alaikum, my dear students. My name is Mahvish Kazmi. I hope you all are doing great and must be focusing on your studies. Okay, so in today's video, our topic of concern are what is energy, what is the definition of energy, why do we need energy, and what are the forms of energy. So let's see first of all what is energy. How we can define this term energy. Energy can be defined as a body possesses energy if it is capable to do work. Any body which can do any work, it means it must be possessing some amount of energy. If even I am giving this lecture to you, if you are listening to me, to absorb all these, you need some energy. If you want to play any game, you need energy. Okay, it means that to do any work, we need energy. So why do we need energy? To do work. Because without energy, we have no ability to do work. Okay, so what are the forms of energy? We have different forms of energy like mechanical energy, thermal energy, nuclear energy, chemical energy, electromagnetic energy, sonic energy, gravitational energy, kinetic energy, potential energy, and ionization energy. So many types of energy we have. In this video, I will tell you about the mechanical energy. How we can define this mechanical energy? What is this mechanical energy? We say that mechanical energy is the sum of an object's kinetic and potential energy. Okay, so this mechanical energy is the sum of kinetic energy and potential energy. But what is this kinetic energy and potential energy? We will go further on this topic to know about the kinetic energy and the potential energy. Okay, so let's see how we have defined the mechanical energy. The definition is the energy due to position or due to the movement of something. As I have told you, it is the sum of kinetic energy and the potential energy. So we can say there are two types for the mechanical energy. One is kinetic and the second is potential energy. Okay, so what is this kinetic energy? What is the definition of this kinetic energy? Kinetic energy is the energy that objects possess due to their motion. Any object which is moving, it must be having some kinetic energy. It means that every moving body possesses this kinetic energy. But how we can derive this kinetic energy? What are the examples of this kinetic energy? Let me tell you some examples of this kinetic energy, like shooting a rubber band. If you are trying to shoot a rubber band, if the water is falling over the fall, or yo-yo in the motion, or releasing the arrow from the bow. So all these are the examples of kinetic energy, because in all these phenomena, in all these examples, objects are moving. And I have told you kinetic energy is concerned with the moving objects. Okay, so how we can derive the formula of this kinetic energy? Here we have a diagram and here we have some explanation. Consider you have a body of mass m moving with velocity v. Let's see on this. We have a block of mass m and this block is moving with velocity v. And after some time, when you will apply some force on it, then what changes will come into this block? Okay, the body stops after moving through some distance as due to some opposing force, such as force of friction acting on it. It means if that block is moving and covering distance as, and if you have applied force on it, let's suppose force of friction is acting on it, then this block will stop after some time. Okay, the body possesses kinetic energy and is capable to do work against this opposing force F until all of its kinetic energy is used up. This block, which was moving with velocity v, it will continue to resist. it will continue to resist against the frictional force. Okay, until how? Okay, here we have some derivation steps. Since I have told you kinetic energy is defined as the capability of any body to do some work, or any body which is moving, which is capable to do some work, it means it is possessing some amount of kinetic energy. Okay, so we have studied before the formula for work is equals to F cross S. Work is the product of force and the distance. Kinetic energy will come like this. Initially the body was moving with velocity v, and after some time when you have applied some force on it, that block has been stopped, so final velocity will be is equals to 0. Okay, and the force you are applying is equals to ma. We know by the Newton's second law of motion F is equals to ma, and when you will separate the term a, then the formula will become a is equals to minus F over m. Why I have placed the minus sign over here? Because we have applied the force opposite to the direction of motion of the body. Okay, we have applied the force of friction which is acting opposite to the motion of a body. So that is why I have placed minus sign with this force. So the acceleration would become a is equals to minus F over m. Now I will use the third equation of motion and I will put the value of this acceleration in that. Third equation of motion is 2as is equals to vf square minus vi square. So in place of acceleration I will put minus f over m, as will come like same. Vf is 0, so I will take the square of 0, which is 0 obviously, and minus initial velocity is equals to v, so I will take the square of this velocity. So by arranging this equation I will get Fs is equals to 1 by 2 mv square, and Fs is equals to kinetic energy. So this is the formula for the kinetic energy, that kinetic energy is equals to 1 by 2 mv square or half mv square. I hope you have got this derivation of kinetic energy. Now next move towards our next type of mechanical energy. This is potential energy. How we can define this potential energy? Very simple definition. The energy possessed by a body due to its position is known as its potential energy. Okay, how we can define this potential energy? The energy possessed by a body due to its position is known as its potential energy. Okay, so here we have some of the examples of this potential energy, like stretching a rubber band. When you are trying to stretch a rubber band, then its position is changing, so it means that you are means that rubber band has some potential energy. Similarly, water at the top of a waterfall, if the water is running down from a waterfall, then its position is changing, right? So it means it possesses potential energy. And then stretching a bow, in case of stretching a bow, again the position has been changed, so it means that a bow possesses potential energy. So how we can derive this potential energy? What is the formula for this potential energy? So for the derivation, let's see our explanation. Let a body of mass m be raised up. As you can see in this slide, a blue color ball has been raised to some height h, and the mass of this ball is simple small m. The body will acquire potential energy equal to the work done in lifting it to the height h. We say that if we are lifting this ball, if we are lifting this mass from the surface of the earth to some height h, then we are doing work on it. This body is doing some work. This body is capable to do some work. Okay, so it means it possesses potential energy. So here we will take the derivation for this potential energy. Potential energy would be is equals to F cross H. Like before, in kinetic energy I have equalized kinetic energy is equals to work done. Similarly, potential energy is also is equals to work done, and the work formula is force multiplied by distance. Here our distance is h, our distance is replaced by height h. So the potential energy is equals to F cross H, and the mass of that object, if that mass possess some weight, so that is why F is equals to weight, and weight is equals to mg. So in place of W I will put mg, then the formula will become for the potential energy mgh. So the potential energy depends on mass and height. Okay, and this is the product of gravitational acceleration as well. So the potential energy is the product of mass, height, and the gravitation acceleration. Now let me tell you some another important point, that energy can be transferred from one form to another form. Means the kinetic energy can be changed by the potential energy. Like how? Look at this example. This girl is having a ball and she is standing at some height. Okay, so at this height and at this position the ball is having potential energy. When she will drop this ball from this maximum height, from this maximum position towards the earth, then all of the potential energy will convert into the kinetic energy, because the position is changing, because the ball is moving from the maximum position and the ball is coming towards the earth. So the ball is covering some distance, the ball is doing some work, so all of the potential energy is transferred into the kinetic energy. Okay, now look at this slide. Here we have again that maximum potential is at the maximum height, and when the ball come down to the ground, then all of its potential energy convert into its kinetic energy while reaching to the ground. आई होप आपको आज के टॉपिक समझ आ गए होंगे. सो प्लीज़ प्रिपेयर दिस टॉपिक्स वेरी वेल. थैंक यू सो मच फॉर वॉचिंग दिस वीडियो.